Hey A&Pers, this is Dr. Jones checking in. This is A&P1 Lecture Test 5, Video 15, covering page 16. And so now we're going to finally talk about the synapse. The synapse is where a neuron communicates with another cell. There are different types of synapses. Electrical synapses are rare. Fascinating. Next, chemical synapses are the kind that we've been talking about where the synapse releases a chemical, generally a neurotransmitter, into the synaptic cleft, which binds to receptors on what we're now going to call the postsynaptic cell. So the presynaptic cell is the neuron that sends the message. So this is going to be our presynaptic cell here. And then the postsynaptic cell is the cell that receives the message, the one with the neurotransmitter receptors in its membrane. Next term on the list, I'm trying to go in order, is the synaptic cleft. The synaptic cleft is the gap between the presynaptic cell and the postsynaptic cell. And the synapses that we've talked about so far are a specialized type of synapse called a neuromuscular junction, where the presynaptic cell is a motor neuron and the postsynaptic cell is a skeletal muscle cell. And so the synaptic cleft in that instance is the gap between the nerve cell and the muscle cell. And so now we're going to back out and learn the exact same thing over again, but with more general terms to describe all synapses and not just neuromuscular junctions, which is a synapse between a nerve and a muscle. We're going to learn the terms that include a synapse, which is just, if they just say synapse, they're talking about a nerve talking to another nerve. Neuromuscular junction is a synapse with a muscle cell. A neuroglandular junction is a synapse with a gland cell. Next term, neuromuscular junction, is a synapse between a nerve and a muscle cell, as discussed. But now we're learning about neuromuscular junctions, a synapse with a muscle cell, before we learned about neuromuscular junctions specifically involving skeletal muscle cells. So now we're going to include all muscle cells. Neuroglandular junction is a synapse between a nerve cell and a gland cell, as discussed. Neurotransmitters are the chemicals that are released at the synapse from the presynaptic cell into the synaptic cleft. The presynaptic membrane is this right here. It's the membrane of the presynaptic cell that releases the neurotransmitter. No, I want blue. And the postsynaptic membrane is the membrane of the postsynaptic cell with neurotransmitter receptors that receives the message. So what did we call the postsynaptic membrane in a skeletal muscle cell? The motor end plate. You got it. To communicate. An action potential. So we're in the sentences under the boxes now. Under the box now on page 16. An action potential propagating along the presynaptic membrane of the presynaptic cell releases chemicals called neurotransmitters from synaptic vesicles into the synaptic cleft, where it binds to chemically gated ion channels, neurotransmitter receptors, and of course they're chemically gated because we're binding a chemical to them, and that's what opens them. So the chemical is what opens the gate. And they're binding to chemically gated ion channels on the postsynaptic membrane of the postsynaptic cell. I know, lots of new terms. But it's something we've talked about before. We're just throwing new terms at it to make it a more general concept to include all synapses. Excitatory neurotransmitters. Let me find that on my other note set here. Excitatory neurotransmitters. That one's on the next page. No. I rearranged a little bit. Excitatory neurotransmitters cause depolarization. Exciting depolarization. Yeah, that makes sense. That makes sense because depolarizing brings it closer to threshold. Excitatory neurotransmitters bring depolarization and promote the generation of action potentials. Inhibitory neurotransmitters cause hyperpolarization and suppress the generation of action potentials. So what the synapse creates in the second neuron is a graded potential. So we just brought it all together back to the beginning. And what happens in the postsynaptic cell is a graded potential. True story. The effect of a neurotransmitter on the postsynaptic membrane depends on the properties of the receptor, not the properties of the neurotransmitter. Let's see. Oh, it's supposed to be on. Yeah, I think that's the next page of Noteset. So we know that, I'm trying to think of the best way to say this. We know that in a neuromuscular junction, acetylcholine binds to sodium ion channels and causes depolarization in the skeletal muscle cell. But at some synapses, acetylcholine binds to potassium ion channels and is therefore inhibitory, taking those cells further from threshold. So it's not the neurotransmitter, it's it's the nature of the receptor. It's an acetylcholine receptor, but is it an acetylcholine-gated sodium ion channel, or an acetylcholine-gated potassium ion channel, or even a calcium ion channel? I mean, there are other ions. We've just tried to keep it simple. K-I-S-S, keep it simple, stupid. So it's acetylcholine, well, in skeletal muscle cells, causes an excitement, a muscle action potential. In some other postsynaptic cells, if they're a different receptor, can have the opposite effect. Just so you know. Okay, that's all I'm going to say about that. So this has been A&P1 Lecture Test 5, and we covered, this was video 15 covering page 16. Thank you, as always, for joining in. The education must go on. It's good to virtually see you here. Dr. J out.